Alright, good morning. I am making a video on Standard 6.6 about seasons. I hope you're enjoying your days off, or if we're back to school when you're watching this, I hope you enjoyed them. Because we are at home, I'm going to make this video on my couch, which is pretty awesome. But I do have cats and dogs in my house, so if you hear a meow or a bark, I apologize for that. Here we go. The reason we have seasons is because our Earth's axis is tilted. So the axis is that kind of imaginary pole that runs through the center of Earth. So when people think of the North Pole and the South Pole, sometimes we imagine this little pole sticking out of the ground at the top and the bottom of our Earth. It's really an imaginary line, but it is like the center point of our Earth. And that's the point at which our Earth rotates or spins. And remember that one spin around gives us a day, and we spin around 365 times on our trip around the sun, which is called a revolution. So that point at which we spin, our axis at points in our revolution tilt toward the sun and on the northern hemisphere, and at points on our revolution we tilt away from the sun. So the reason this tilt makes a big, huge difference, it's not that it puts us closer to the sun or further away from the sun. It's that it puts us in line with direct contact, more direct rays from the sun, so we get more of the sun's energy. Remember, we talked about biomes and we talked about ocean currents. Those tropical rainforests that run around the equator of our Earth, they're tropical, they're hotter because that equator gets more direct sunlight. It gets more direct contact with the sun's energy. This is why the oceans around the equator have more warmth, and so that warm water is going to rise up in our convection current and it's going to move toward the poles, because that water at the poles is getting less direct sunlight, and so it's much colder and that's more dense, and so that water is sinking and it's moving toward the equator. So we get that convection current that moves the water and moves the heat around our globe so that we don't have a super hot patch around the middle and even colder parts in other parts of the world. Well, that direct sunlight on the equator is pretty constant, but because of the tilt on our revolution around the sun, in the northern hemisphere we have months where we are actually tilted a little more toward the sun, and that's why we have summer. And there are points in our revolution around the sun where we're tilted away from the sun in the northern hemisphere, and that gives us winter. Whatever season we have in the northern hemisphere, the southern hemisphere has the opposite season, because when we are pointed toward the sun and we're getting summer months, they're pointed away and they're getting winter months. When we are pointed away in the winter, they're pointed toward the sun in the summer. And then there are parts of the globe that no matter how we're tilted, they're still getting very indirect contact with the sun's energy, so they always stay colder, like our poles. And there are places on our globe that no matter which way it's tilted, they're going to get more direct contact, like our equator, and they're going to have warmer days. So let's look at the diagram. This picture is a little blurry, but it still gives us the idea. On this one, we're going to start with the Earth that is drawn on the right. When you look at this Earth, it's dated December 21st. So in our head, because we live in the northern hemisphere, when I hear December, I think winter. If I lived in the southern hemisphere and I saw December 21st, I'd be thinking summer. It's always the opposite. So if you look at this Earth and its drawing, you see that the Earth's axis, that little line that's coming out of the top and the little line that's coming out of the bottom, it is tilted to the right. But that points that northern hemisphere on the globe away from the sunlight. And so in this particular drawing, the northern hemisphere is experiencing winter. And because it's always the opposite, we know that the southern hemisphere, or that bottom half of the sphere, the bottom half of the circle, and hema is half, so the bottom half of the circle of our globe is having summer because they're tilted toward the sun. Seasons always go in the same order. They never switch up on us. Thankfully, we know what's coming next. So we're going to move in a counterclockwise direction. just like we rotate, just like the moon revolves around us, the Earth's going to revolve around the sun in a counterclockwise direction. So we're going to move back here to March 21st. And March 21st is indicating for us spring, because after winter, thankfully, we have beautiful days of spring. Now, in this position, you can see that the Earth is not really tilted toward the sun or away from the sun. It's kind of just there. And so think about spring. We have days that are kind of right there in the middle. They're not too hot, they're not too cold, they're kind of just perfect with beautiful flowers, and we get excited about warmer days. The Earth's going to keep on revolving, and we're going to come over here to June 21st. Now in the northern hemisphere, you can kind of see that that top half of the sphere, the top half of the circle, is pointed toward the sun just a little bit, and this is going to give us warmer days, and we have summer. But the folks in the southern hemisphere are pointed away from the sun, so at this point in the year, they're having winter. After summer, we always have fall, and you can see again that the Earth is not really tilted toward the sun or away from the sun in any way, but it is kind of just like straight on to the side. So in this point in the year, we have not too hot, not too cold, kind of just right, perfect fall days, my favorite season. And then the revolution keeps continuing, and after fall, we have winter again, back to spring, to summer, to fall. Now, don't always think that it goes in this order in a drawing, because remember, just like the moon phases, and I could draw the sun anywhere in the diagram and you guys can put in the moon phases, for this particular diagram, I can look at things from a different angle. So here we go. Now we're looking at it from a different angle, and in this case, this image on the right, the Earth is pointed toward the sun in the middle. So in this particular diagram, I have to look at my axis first, because it's always about which way the axis is tilted, not in which spot on the paper is the Earth drawn. So I'm going to look at my axis, and this image on the right, this axis is tilted toward the sun. So for this particular picture on the right, where it's tilted toward the sun, it says June 22nd, and summer solstice. We know that the northern hemisphere is having summer, and the southern hemisphere is going to have the opposite season, which is winter. You'll notice in most diagrams, when they are labeled for us, it's labeling the seasons for the northern hemisphere, because that's where we live. I would suppose that if we lived in the southern hemisphere and we looked at a diagram, they might label those seasons in the opposite way. Be sure when you look at questions on quizzes, on TCAPs, on anything that you come across, that you pay attention to which hemisphere you're being asked about, because it's really easy to go ahead and automatically assume we're talking about the northern hemisphere where we live, but test designers and question writers like to make sure you're paying attention, and they might ask you about the southern hemisphere. So please pay attention to what hemisphere they're talking about. So again, let's look at this drawing on the right. We have the Earth tilted toward the sun. The northern hemisphere has summer. And so we're going to move in a counterclockwise position. And up here we have the autumnal equinox. Autumnal means fall. So we have fall in the northern hemisphere. If we have the opposite season in the southern hemisphere, you can guess now that it is spring, because it always comes in the same order. After fall, we have winter. So here in the picture to the left, you can see that the Earth is pointed away from the sun. They're saying it's 23.5 degrees, which may be right. So we're pointed away from the Earth, and in the northern hemisphere, we are having winter. In the southern hemisphere, we are having summer. After our winter in the northern hemisphere, we move again, and we have spring, which you will sometimes see as vernal equinox. Don't let the crazy words vernal and autumnal mess you up. You know the order, so summer, fall, winter, spring. Let's talk about these words that just popped up in the last drawing. The first is solstice. A solstice is from Latin, and it means the sun stands still. Well, we know that nothing's really standing still. We are in constant movement, and we're constantly moving around our sun. And our sun's not really sitting still because it is in constant movement around our galaxy. But to us on Earth, it looks like the sun is kind of holding still for a while. In a solstice, it is where the Earth is tilted most toward the sun or farthest away from the sun. So in the summer, we have a summer solstice. This is our first official day of summer. And this is when we have the most hours of daylight and we have the fewest hours of night. So you can see why somebody would say the sun stands still, because they're experiencing way more hours of sunlight than they're used to, or they're experiencing way more hours of darkness than they were used to. You know that when we get towards summer, there seems to be way more hours of daylight. And as we get through fall and into winter, we get fewer and fewer hours of daylight, and it starts to get dark around 5. In the summer, it starts to get dark around 9. And that has a little to do with daylight savings time, but mainly it's about our tilt toward the sun. So remember, solstice is summer and winter. Summer is the most hours of daylight in the year. Winter is the most hours of darkness we have in the year. The next term that you'll need to know is equinox, and it means equal nights. This one's a little easier to remember because equa is the start for equinox, and it's the start for equal. So at an equinox, this is where the sun is kind of lined up with the equator. It's not tilted toward the sun, it's not tilted away from the sun, and we have this in the spring, and we have this in the fall. So in the spring or vernal equinox, we have equal hours of daylight and darkness. And at the autumnal or the fall equinox, we also have equal hours of daylight and darkness. So let's look at this picture, and it gives us that diagram again, but it also labels our winter solstices, winter and summer solstice, our vernal spring, or our autumnal equinox. So remember, winter and summer we have solstice, that's the longest hours of daylight or darkness, and equinox is equal hours of daylight and darkness. So let's just run through this diagram one more time so we have some practice. Let's look at the Earth on the right. We have a tilt of 23.5 degrees. The axis is what I'm going to look at, and they drew 2 little red lines just to mess with our heads, but we're going to look at that one that goes all the way through. And you can see that that axis is tilted away from the sun, so that I know in the northern hemisphere I am having winter. On the day of December 21st or 22nd, I'm going to have the longest hours of darkness and the fewest hours of daylight because of this tilt. After winter, we have spring, and up here at the top we can see that the axis is not tilted toward or away from the sun. It's just there happily in the middle. We have equal amounts of daylight and darkness on March 21st or 22nd. That's our spring or vernal equinox. After spring, we always have summer. And you can see that the axis is tilted toward the sun in the northern hemisphere. At this point, we're going to have the most hours of daylight and the fewest hours of darkness. We'll have our summer solstice. After summer, we always have fall. And again, our axis isn't tilted toward or away from the sun. We're in that happy middle place. And on September 22nd or 23rd, we have the autumnal or the fall equinox. Remember, equinox is equal days and equal nights. So let's do a really quick review. Seasons are caused by the tilt of the Earth's axis as it revolves around the sun. Always remember, our seasons are caused by the tilt of the Earth's axis at 23.5 degrees. The amount of direct contact from the sun's energy is what makes it warmer or colder, not whether we're farther away or closer to the sun. When the axis is tilted toward the sun, that hemisphere is experiencing summer. When the axis is tilted away from the sun, that hemisphere is experiencing winter. Always look for the axis in the drawing on the diagram. That's how you tell what season you're experiencing, not whether it's on the left-hand side or the right-hand side or the top or the bottom, because we can change our perspective in space. So make sure you look for that axis and which way it's pointing. Pointing toward the sun, you have summer. Pointing away from the sun, we have winter. Seasons always go in an order in a counterclockwise direction. So we always have summer, fall, winter, spring, or it may go winter, spring, summer, fall. I always like to keep things kind of in my head with school because that's kind of the central point of my year. So we have, let's say, summer. We have summer vacation. Yay, right? So we have summer vacation. We're out for summer, those hot, warm days where we're tilted toward the sun. After summer vacation, we come back to school every fall. In the fall, we have kind of that happy middle where it's not too hot, it's not too cold. We're somewhere happily in the middle. The leaves fall from the trees in the temperate deciduous forest to conserve water because we're moving into winter. So after fall, after school starts, throughout the school year, it gets colder. We're in winter now. We love our snow days. Not so much being sick, but we do like our sick days. And those winter days, our hemisphere is pointed away from the sun. After winter, we're going to move into spring. We get spring break coming up in March. And in the spring, our hemisphere is not pointed really toward or away from the sun. We're in equal kind of direction. That's where we have our spring or vernal equinox. Spring, we get the beautiful flowers and the nicer warm weather, which slowly moves us into summer again. Remember, equinox is an equal amount of daylight hours and dark hours. Autumnal means fall. Vernal means spring. And a solstice is where the earth is either tilted the farthest away from or toward the sun. Our summer solstice means we have the most hours of daylight and the fewest hours of darkness. And our winter solstice is the fewest hours of daylight and the most hours of darkness. I hope this video helps. If you have any questions while you're at home and you're working on Standard 6.6, give me an email in Canvas. I'll check my email pretty regularly over the next few days.